I'm going to go over a few problems from the Math 3 Unit 2 Worksheet 7, starting with number 2. Here we have the graph of y equals f of x and the graph of y equals g of x. F of x is your parabola, g of x is the line, and A says list all the labeled points that are solutions for f of x equals 0. So f of x equals 0, that belongs to the function f, and that's saying all the y values are 0. That happens on the x-axis. So in other words, these are x-intercepts for f. And so if you follow f is a parabola, it crosses at point A and then comes back and crosses the x-axis at point D. So A and D are the two x-intercepts of f of x. Part B lists all the labeled points that are solutions for g of x equals f of x. This is where the two graphs cross or touch each other. The parabola and the line cross each other at point A and at point C. Part C lists all the labeled points that are solutions for x equals 0 on the graph of f of x. So, two requirements. It's got to be a point on f of x, and the x value has to be 0. If the x value is 0 and it's on a graph, this is talking about a y-intercept. Where is it touching the y-axis? Because all y-intercepts have x values of 0. And so if we trace along the graph f, we see point E, which looks like the vertex, is the x-intercept. Sorry, the y-intercept. D says to list all the labeled points that are solutions for y equals f of x. So these are just all the points on f of x that are labeled. F of x, or any continuous graph, is made up of an infinite number of points. So it's not asking us to list all those points, it's just the ones that are specifically labeled. So if we go along f and just list all the points that are labeled on f, so starting with A, then E, then D, then C. And then list all the labeled points that are solutions for y equals g of x, so that's all the points on g of x. Go along g of x, we see point A, and then point B, and then point C. For number 3, we have the graph y equals f of x, which is our horizontal line, and we have the graph y equals g of x, which is, looks like maybe a cubic function here. How many solutions are there for g of x equals 0? So remember, if you have a function like this equal to 0, that's referring to x-intercepts. So it's saying how many times does g of x cross the x-axis. So I'll circle those spots, 1, 2, 3. How many solutions are for g of x equals f of x? That's asking the question, how many times do the two functions cross? I'll highlight. We see 1, 2, 3 spots. Part C is asking us to evaluate f of 2.5. So if we go to 2.5 on the x-axis, about right here, and look at what's the value of f. Because f is constant, f is always going to have a y value of 2, so this is a pretty easy one. It doesn't matter what you plug in for f, you're going to get 2 for an answer no matter what. D, how many times does g of x equal 3.5? So that 3.5 is a y value, and I'm going to go label or find out where 3.5 is on the y-axis. It's about right here. And imagine a horizontal line going through 3.5 and ask yourself, well, how many times would g cross that? Well, 1, 2, and then eventually 3. The arrow doesn't, like on the graph that we see, it doesn't cross it, but that arrow means it's going to eventually go through that graph. So 3 spots. E, on what approximate interval is g of x less than -1? Okay, so that -1 is a y value. So locate -1, and I'm just going to draw a horizontal line at -1. Okay, and I'm going to highlight the part of g of x that's less than -1. So this part is underneath it, and this part is underneath it. And we're approximating, or kind of guessing. And so the first highlighted part looks like it goes from -infinity, these are x values, up to the x value of -1. The second highlighted part looks like it starts at x equals 1, 2, 3, 4, 5, and goes to 6, 7, 8, 9, 10, so 5 to 10. I'm writing open intervals here. You could do closed intervals. It doesn't specify what kind of interval. I'm just going to do open intervals right here. F asks how many roots does g of x have? A root is another word for x-intercept. So if you didn't know that, take note of that. So this is talking about a root is where it crosses the x-axis, as long as it's a real root. Okay, and we're going to assume we're talking about real roots here. So this is really the same question as A, because a solution, again, if we're talking about real solutions and real roots, they're both the same question. Of g of x equals 0 or a root. And so we're going to have the same answer. And last one, part G asks, is g of x equals 0 between f of 4 and between x equals 4 and x equals 5? In other words, is g crossing the x-axis, because that x-axis is height 0, between 4 and 5? Well, let's find out. 1, 2, 3, 4. Here's 4. Here's 5. And we see that it is crossing the x-axis between 4 and 5, so we say yes. Number 4, I'm going to do just a few of these. We'll start with A. And we need to state whether the following statements are correct or incorrect. So assuming this function is f of x, it's not labeled, but everything refers to function f. So it's asking if f of 4 is greater than 0. So go to x equals 4, and f of 4 is 2, because here's the point, 4, 2, x is 4, y is 2, so we know f of 4 is 2. So is 2 greater than 0? Yes, it is. And so if it's correct, we're going to write A. Let's skip to part D. It says f of 2 equals 0. F of 2 is, well, the point at x equals 2 is 2, 0. So f of 2 is 0. That's true. So I'm going to put A. Let's look at part H. F of x has a relative maximum at 4, 2. So I'm going to go to the point 4, 2. We've already kind of highlighted it. And we're increasing here. And then we're constant here. So 4, 2 is the point where it changes from increasing to constant. That is not a relative maximum. A relative maximum is a point where it changes from increasing to decreasing. And so this is false, and so we write the letter B. or incorrect. Skip now to number 7. Number 7, we have a table that shows several points on 3 continuous functions f, g, and h. And if it helps, you can plot those points, and let's do that first. So f, so 0, 3, 1, 1, 2, 3, 3, 5, and 4, 7. I'm going to plot those points for f. So 0, 3, 1, 1, 2, 3, 3, 5, 4, 7. And we're not sure what happens between the points. It may dip down further, or I'm just gonna connect them with the shortest distance possible. So we know they're continuous. Now let's do g of x. I'll switch colors. So f is in blue. G I'll do in green. So 0, 0, negative 1, negative 3, 1, 0, sorry, 2, 2, 1, 3, 7, and 4, negative 2. Again, I'm going to just connect the points with the shortest distance possible. And then the last one I will do in this color. So 0, negative 4, 1, negative 1, 2, 0, 3, 4, and 4, negative 3. Okay, something like that. And now we're going to try to answer these questions. So part A says, on the number line below, shade the intervals between the integers where the solutions to f equals g must exist. So where is the blue crossing the green? Okay, so if I look, blue's crossing green somewhere. Okay, I'm gonna write something in here. So this is x equals 1, 2, 3, and 4. And so between what two x values is the blue graph and the green graph crossing? So I'll highlight here and here. Those are the two spots where I see blue and green crossing. So between 2 and 3, and between 3 and 4. They're not crossing everywhere in between, but somewhere in between. Part B, on the number line below, shade the interval or intervals between the integers where the solutions to f of x equals h of x must exist. If it is not necessary that a solution exists, explain why. So now we're looking at f and h, so blue and red. Do the blue and red ever cross? And looking at them, they never do. And so that's what we write. No solution is necessary. And we say necessary because we don't know for sure if there is a solution or not. But if, based on the information given, we plotted the points we know, nothing has to cross. So no solution is necessary. since it is possible the graphs don't cross. Part C. On the number line below, shade the interval or intervals between the integers where the solutions to g of x equals h of x must exist. So now we're looking at the green and the red. So the green and the red cross, I'm highlighting in blue here, two spots between 0 and 1 and between 1 and 2. So 0 and 1, there's one solution there where they cross, and between 1 and 2 is another solution where they cross. D, on the number line below, shade the interval or intervals between the integers where the solutions to g of x equals 2 and h of x equals 2 must exist. If it's not necessary the solution exists, explain why. So we want an interval where both of these are true. It says the word and, so both g and h have to have a value of 2 within that interval. And then looking on at D and E, D is talking about G and H, E is talking only about H. So I'm going to go and erase F, so we don't need it anymore. And we're talking about the value 2, so what I'm going to do, here's 2 on the y-axis, I'm going to draw the equation y equals 2. And we're looking for where both the green and red, so between 2 and 3, notice that both green and red reach that height. And also between 3 and 4, notice green and red also reach that height. So 2 and 3 and 3 and 4. And last one, on the number line below, shade the interval or intervals between the integers where the solutions to h of x equals 0 must exist. So this is only talking about h, so I'm going to erase g now, just to make it easier to see some stuff here. And we want to know where h is equal to 0. So y equals 0 is our x-axis. Where is it crossing the x-axis? Well, it's on the x-axis at 2, and somewhere between 3 and 4. So between 3 and 4, and exactly at 2. So that's what I'm going to do. And we'll stop there.